this video, we cover the organization of data within a project, give an overview of a basic geological model, and review the different outputs available from a Leapfrog project. To start this tutorial, I'm going to open an existing project file. Using this project, I will talk about the way data in Leapfrog is organized by looking at the folders in the project tree that contain the data that is used to build the geological model. I will start by clearing the scene so that we can view the different data types as they are discussed. Let's start at the top with the Topographies folder. This is the folder where the topographic surface is created. The project tree is organized such that the object of interest sits at the top, and all of the components that go into making up that object sit below. The top-level item within this folder is the topography surface itself, and below the surface is a hyperlink to the points that were used to create the surface. Next, we'll take a look at the drill hole data folder. By expanding the folder, I can see the different drilling tables. To open any table, simply double-click the item in the project tree. I could take a look at the collar data, or I could take a look at my lithology data and the different columns available there. You'll see that the columns in the table are represented by different objects that sit below that table in the project tree. For example, we can see that the lithology table contains columns for rock, grouped, and split dacite. We can also see these different columns available here within the project tree. To view the lithology data in the scene, I could either drag out this entire table, or if I would like to view a specific column of data, I could simply select that column and drag it into the scene. Once the raw data is imported, which in this case is the topography surface and the drill holes, we can start building a geological model. Let's take a look at the structure of a geological model in Leapfrog. There are 5 subfolders within each geological model. They are the boundary, the fault system, the lithologies, the surface chronology, and output volumes. The contents of the boundary folder control the size and shape of the model. By default, the boundary comprises the overall model extents assigned when the model was set up, and the topographic surface if one is loaded into the project prior to creating the model. The boundary can also be modified by adding a new lateral extent or a base, both of which can be built from polylines or structural data created in Leapfrog, or by importing data that represents the desired boundary. The boundary can be modified by double-clicking the boundary folder. Model extents can be changed by either manually editing, enclosing a particular object already loaded in the project, or by adjusting the toggles in the scene. The fault system folder is where faults can be added to the model. Many faults can be added and set up to terminate against one another. Once the faults have been added and activated, the geological model will be split into multiple submodels. There are no faults in this demonstration project, but they will be covered in more detail in a different video. The lithologies folder contains the lithologies available for modeling. These are specified when the model is set up. In this case, the split dacite column of data was used. The hyperlink will take you to that item in the project tree. Additional lithologies can be added to the model if necessary by simply double-clicking the lithologies and adding a new one. In this case, there was an additional lithology added called failure plane, and we can tell that because it is bold, whereas the ones that were imported at the time of the creation of the model are not. The surface chronology folder is where the majority of the modeling occurs. By clicking on the little black triangle beside it, we can see the different surfaces that were used to create our geological model. There is already one erosion surface, one vein system, and 2 intrusion surfaces. To build a new surface, simply right-click on the surface chronology folder. Each of these different surface types is suited for modeling in different geological settings. The functionality and purpose of each of these different surface types is discussed in a different video. While these surface types have geologically specific names, such as new deposit, new erosion, new intrusion, new vein, their underlying functionality can be used to model any type of categorical data, including weathering, alteration, mineralized zones, structural information, etc. Lastly, the output volumes folder contains the closed interlocking volumes. These airtight interlocking volumes were generated by clipping the above surfaces against each other in a geologically reasonable way. Now that we have discussed the different parts of a basic leapfrog model, I'm going to review some of the main outputs available from a leapfrog project. Essentially, any object imported or created in a project can be exported in different formats by simply right-clicking it, Export. Objects in Leapfrog can be exported and imported to and from a number of different format types, including native file types for several general mining packages.